We're going to continue 6.3, and today we're going to focus on multiplying polynomials. So I've added an essential question. So for part 1, the question was, how do you add, subtract, and multiply polynomials? For part 2, our question now is, what are special product patterns and how can you use them to multiply polynomials? And you've seen some of these before. So I'm going to move on to the next page, to the special product patterns. So there are a variety of special product patterns, and again, some of these you have already seen. So you know the sum and difference pattern, which basically you have two binomials, they have the exact same terms but opposite signs. And what happens when you multiply these? Well, your inners, your b times a, and your outers, negative b times a, I'll say, those basically cancel out. And so you're left with just the first terms being multiplied and the last terms being multiplied. Or in other words, we ended up calling this a difference of two squares. And that's actually one of your factoring friends. So when you saw a difference of two squares, you were able to factor it into a sum and difference pattern. So a quick example here, hopefully you're becoming really familiar with this. You notice two binomials, they have the exact same terms. If you multiply the inners and the outers together and then combine them, they're going to cancel out. And so really you are just left with the first terms being multiplied to give you x squared and the last terms being multiplied to give you negative 25, and that is a difference of two squares. The next one that we are already familiar with is the square of a binomial. So for the square of a binomial, notice that you have a binomial like a plus b or a minus b, and those binomials are being squared. And yes, that is the exact same thing as taking a plus b times a plus b and distributing that out. And when you do that, what you end up with is the first term gets squared. The inners and outers are exactly the same thing. So here you have a times b and a times b, and when you add those together, you get that 2ab. So that's where that middle term comes from. And then the last term is also squared. And the only difference between these two is that the second one is a subtraction. So you have a minus b, which is just going to change the signs of those middle terms. Since everything else is just being squared, first term squared, last term squared, those just stay positive. Middle term, inners and outers will be negative, and now you get a negative middle term. And hopefully you recognize that these two are one of your factoring friends. They were called the perfect square trinomial, because the first terms and the last terms were perfect squares, right? And then you multiply them together, you double them, you get those middle terms. So thinking of that super quickly for x plus 5 squared, instead of writing it out like we would over here, let's just think to ourselves, this is the square of a binomial. I recognize that. So I know that when I multiply that out, I am going to square my first term. My middle term comes from basically taking the x and the 5, so the two terms, they get multiplied together and double them. So we double the 5 times the x, or the x times the 5, and that's where that middle term comes from. And that's what's right here. And then we square the last term, 5 squared. So you can take this step, or like the way that I do it, I just recognize it's the square of a binomial. First term gets squared. Second term comes from multiplying the two terms and doubling them. So 5x times 2 would end up giving me 10x, last term squared. And there you have it. I'm going to actually go up here and box that one in too. Now the last special product pattern that we have is new to you. Cube of a binomial. So the cube of a binomial is a special product pattern. If you have a binomial, just like we did above, instead of squaring it, now we're cubing it. And once you recognize what a and b are, or the first term and the last term in the binomial, basically you cube the first term. And then you follow this pattern. So your coefficient of your second term is 3. Notice then that A gets 1 less power. So A was third power. Now it went to 2 power. But B comes to the first power. And notice that these powers add up to 3, the same power as the binomial. The next term has a coefficient of 3. A gets 1 less power, so now it's down to 1. And B gets 1 more power, so it's up to 2. Still notice those powers add up to 3. And then the last term is B cubed. And, you can take the long route and you can do this. But that's going to get complicated as we move forward and have binomials raised to any power. So it's a good idea to start recognizing these patterns. And the only difference between these two patterns, when you are subtracting A and B, so when you have the cube of a binomial is a subtraction between two terms, the signs are going to alternate. So the first term is positive, but that second term is negative because now B is actually negative, right? And so you're going to have that negative B thrown in there, so you're going to have a negative second term. So on the third term, that B gets squared, making it positive. So the third term is positive. And then the last term, you're going to have that negative B cubed, which is going to make it a negative. So let's do our example here. I've got x plus 5 to the third power. That is a binomial raised to the third power, so it is in fact a cube of a binomial. My a here will be my x, and my b here will be my 5. So instead of using a and b in the pattern, I'm just going to use x and 5. All right, so the first term is going to be x cubed. Imagine you came over here and you multiplied all your first terms together. You would end up with an a cubed. Okay, and that's where that's coming from. Well, this time I'm going to do x cubed. And you can think to yourself, hey, there really is a b or a 5 to the 0 power, but you don't need it here. Okay, then I'm going to use that coefficient of 3. Now I'm going to have my a or my x squared. So x gets 1 less power, and now we're going to bring the b or the 5 onto the scene, and it gets one of the powers, so that the powers all together add up to that third power. 2 plus 1 is 3. Okay, next coefficient is also going to be 3. This time our x gets 1 less power, so it's down to x to the first power, and 5 is going to take one of those powers, so it's 5 squared. Notice again, still adding up to a degree of 3 every term. Okay, and then my last term, well, that's just going to be 5 cubed, because, again, come back over to this a plus b times a plus b times a plus b. All of those b's get multiplied to give you b cubed, or in this case, 5 cubed. Simplifying, we get x cubed plus 15x squared. Now I got 25 times 3, so plus 75x plus 125. Moving down to example 3. So the goal is to recognize what pattern you have and then follow the actual pattern. So here I notice I have two binomials, the exact same terms. The signs are opposite. So I know that I should be looking at the sum and difference pattern, which when I multiply, inners and outers will cancel out, leaving me with a difference of 2 squares. So for me, super quickly, I'm going to say, hey, this is a sum and difference pattern, and this is going to equal, well, my first one's multiply to give me 9x squared. My inners and outers cancel out, if you don't believe me. But by this point, you should be experts at this. And my last give me -4. And in fact, this is a difference of 2 squares. And hopefully you recognize this, because we will go back to factoring, and you will need this friend in the future again. So if you see 9x squared minus 4, you should be able to factor it into two binomials, a sum and difference pattern. All right, this one, I notice it's a binomial and it's being raised to the second power. So it's the square of a binomial. And I'm going to end up with a perfect square trinomial. So I'm going to take my first term and I'm going to square it. And I'll do it slowly for you. I'm now going to double the product of the two terms. So the 5a times 2, right? Because inners and outers would be the exact same thing. So you'd multiply those and you double it. Okay, and then the last one is just my last term squared, so that 2 squared. So I've followed the pattern to a T here, but really this should be second nature for you now. And you're getting 25a squared plus 20a plus 4. And this right here, this is that perfect square trinomial. This is one of your friends. So now could be an opportunity for you to recognize it if you haven't already. All right, so these are my answers. So nothing new in those two examples. Last example. Notice now I've got a binomial raised to the third power. So this is actually the cube of a binomial. And I promised you one with a subtraction sign. So now you've got a difference of two terms in that binomial and it's being cubed. So we're going to have to be a little bit more careful with this one. First of all, recognize what your two terms are. So you could think of 2m as your A and -3 as your B. And then you can just follow this pattern. So I notice that my A, or my 2m, gets raised to the third power. Then I've got this 3. I promise this 3 comes from somewhere. So right now I'm going to go ahead and just do, hey, it's positive 3. I'll show you where that comes from in a minute. My A is 2m. Okay, so A gets one less power now. A is going to be squared where it used to be cubed. Okay, now in the second term it's squared, which means we're going to bring B in and give it a power. Well, B is -3. So it's -3 to the first power, or just -3. Okay, next part. So that -3, you could have written that as a +3 and made the sign of the second term negative. But it's going to end up being negative anyways. Okay, so following the pattern, I've got a coefficient of 3. My A is 2m. Now 2m gets one less power than it had in the second term. It had a 2. Now it's down to a 1 power. And -3 gets 2 powers. So that the total of my exponents adds up to the cube, right? To the degree of the binomial. All right, and then the very last part of this is I'm going to add, and it's going to become negative because I'm going to take my B, which is -3, and I'm going to cube it. Right, so A gets no more powers, right, because it was at 1, and now in the last term it's to the 0. And B gets all of the powers. It gets 3 powers, or 3 degrees. All right, simplifying. I'm going to have 8m cubed. All right, so I'm going to do exponents first, so that's 4m squared. And I also have this 3 and -3, so that's -9. And I'll go ahead and write 4m squared. I'll come back and simplify that one more time. All right, the third term, well, let's see, that -3 gets squared. And then multiply that by another 3. That's going to give me a +27, which I'll then have to multiply by that 2m. And then -3 cubed is -27. So simplifying one last time. There it is. I've multiplied the 2m minus 3 to the third power. Now, could you have written this out? Sure. You could do this 3 times. Would you get the same answer? Of course you would. It's long and tedious, and it's going to take you a little bit longer. And when we get to more complicated ones, it's going to be more challenging for you. So if we get to a 5th power or a 7th power, it's going to be more complicated. All right, now let me show you where these coefficients are coming from. Where is this, the 1 and the 3 and the 3 and the 1? Where are those guys coming from? Or back to the square of a binomial, where is the 1 and the 2 and the 1 coming from? Well, there is this really cool thing. Pascal figured this out. So one use of Pascal's triangle is this thing of binomial expansion. And I am going to bring your eyes down to the square of a binomial. Look at that. Look at those coefficients. The 1, the 2, the 1. Where do those come from? Well, they come from this third row, which actually this is uneven. So it kind of goes like this. Usually it would be written, I think this is because it was generated by a computer. All right, so, and we'll do the 6th row or the 7th row there in a minute. If you have a plus b to the 2nd power, you can get the coefficients of the product polynomial just from Pascal's triangle. So let me draw your eyes down to the next row. These are the coefficients of the cube of a binomial. Notice over here, the coefficients are 1, 3, 3, 1. So you can use Pascal's triangle actually to find the coefficients for any binomial to any power, which is absolutely super cool. Now I'd like us to continue on to row 6 here, or actually we'll call that row 7 because exponent 0 is row 1, exponent 1 is row 2, and so on. So let's go down to where the exponent is 6 and let's continue Pascal's triangle. So notice along the outsides here, these all become 1. So you're just going to continue your 1 down. And the same is true along the other side of this pyramid or triangle. And in between, what you do is you take the sum of the 2 numbers above it. And this is how this is generated. And it explains a lot of patterns in the world. One of them happens to be binomial expansion, which we're doing right now. And you can continue this triangle forever. And if you look up on my wall in the classroom, if you look it up on Google, there are Pascal triangles that go on and on and on forever. So let's go ahead and let's do a few of these binomial expansions. So for D, I'm actually going to use this row right here. That gives me these coefficients. So I'm going to do the really simple example of a plus b to the 4th power. So here's how you expand it. You take that first term, it gets all the powers. And the first coefficient is always 1. Okay? Then you look at Pascal's triangle and I notice that the second coefficient should be 4. Now my a gets 1 less power, which means that my b gets 1 more power, and those powers together add up to give me the degree of the binomial. Okay, next coefficient is going to be 6. And then a gets 1 less power, and b gets 1 more power. Notice they still add up to 4. Okay, and then we move on to the next coefficient, which Pascal's triangle tells me is 4. A gets 1 less power, so a to the 1st power now, and b gets 1 more power, so b to the 3rd power. And then we move on to the last coefficient, which is 1 again. We're back to 1. A gets 1 less power, so a is down to 0. Okay, so I'm not even going to write that. A to the 0 power, I'm not going to write it, but b gets 1 more power, so it's just b to the 4th. And that's basically how they got that line there. All right, so let's move on to E. Let's make this a little bit more complicated. 2x minus y to the 5th power. Yes, could I multiply this out 5 times? I totally could. I do not want to. Instead, I'm going to use the coefficients from Pascal's triangle, which are right here. I'm going to use this 6th row here to help me get all the coefficients. I'm also going to identify what my 2 terms are in this binomial. So I can see that my a will be my 2x and negative y will be my b. I'm going to start with a coefficient of 1. I'm not going to write it. And my first term, 2x, gets all the powers. So it gets 5 powers, and negative y or b gets none. So I'm not even going to write it. Okay, then to that I'm going to add, and my coefficient for the second term is going to be this 5. 2x, or my a, gets 1 less power, 1 less degree, to the 4th degree. And now b gets to come in, or negative y gets to come in, and gets 1 power, so that those degrees add up to the 5th degree. Next term's going to get a coefficient of 10 according to Pascal's triangle. 2x, or my a, gets 1 less degree. And negative y gets 1 more degree. So that together they add up to 5. Next term, so I'm on my fourth term, gets a coefficient of 10. 2x cubed, or my a, gets 1 less degree. And negative y, or my b, picks up another degree. Okay, moving on to my fifth term, you're going to have a coefficient of 5. A, or my 2x, gets 1 less degree. So it's just to the first degree. And negative y picks up a degree. So it's up to 4. My last coefficient is going to be 1. And I'm just going to take my b, or my negative y, and that gets all the powers. So it'll be plus negative y to the 5th degree. Now it's time to simplify this mess. 2x to the 5th power is 32x to the 5th. So the second term now, notice negative y is to the first power. So the second term is going to be negative. I'll take that, let's go 5 times negative y, which is negative 5y. And I'll multiply it times, that's going to be 16x to the 4th. And I'll come back and simplify one more time. The third term has a negative y being squared. So that's going to make that a positive y squared. So I'm going to have a positive 10y squared, and 2x cubed becomes 8x cubed. The next term has a negative y cubed, which is going to make that a negative y cubed times a positive 10, makes the whole term a negative 10y cubed. And 2x squared will be 4x squared. The next term has a negative y being raised to the 4th power, making that y positive. So it'll be a positive 5y to the 4th times 2x. And the last term is a negative y to the 5th power, making that a negative y to the 5th power. A negative term. I'm going to simplify this one more time, and I'm going to rewrite it with my x's coming first. So 32x to the 5th minus 80x to the 4th y plus 80x cubed y squared minus 40x squared y cubed plus 10x y to the 4th minus y to the 5th. So I did that in just a few lines. I probably could have done it in just 2 lines, but it was a lot easier than multiplying this binomial out 5 different times. Make sure, because it was a subtraction, that your signs are alternating. And what I mean by that is second term's negative, third term's positive, fourth term's negative, fifth term's positive, last term's negative. So that we're following that pattern that we had up here. And I will circle my answer.